Hello students. I have seen number of students solving problems on limit without understanding the concept of limit. Limit is a very interesting concept. Let us see in this video what is actually the meaning of limit. Why we are finding the limit of a function and when it is required. Before going to that, let us see what is a function. Now function is an expression, rule or law that defines a relationship between one variable and another variable. So what is a function? Now it is an expression, a rule or law that defines a relationship between one variable and another variable. So it defines a relationship between two variables. For example, you see here we are having x is a variable and y is a variable. Now and these two are related as y is equal to 4x, and this is called a function because it relates the two variables x and y. Now as per this function, if x is 0, putting here value of x as 0, we are getting y is equal to 4 into 0 is equal to 0. Similarly, when x equal to 1, if we put here 1, 4 into 1 is equal to 4, the value of y, 4. So like that, when it is 2, 8, minus 1, minus 4, minus 2, minus 8, like this. So here, what we are doing, we are independently choosing the value of x and we are getting the value of y from this expression. Therefore, x is known as here independent variable and y is known as dependent variable. If we express the function as y is equal to y, x is equal to y by 4, now here y becomes independent variable and x becomes a dependent variable. So like this, you can change independent to dependent or the equation. If the equation is written in this form, y is equal to 4x, x is independently chosen, and from its value we are getting the value of y. So x is called independent variable and y is called dependent variable. If we express the function in this way, x equal to y by 4, here first you have to choose y to get the value of x. Therefore here y becomes independent variable and x becomes a dependent variable. But we are interested to discuss about limit, so we won't go more into the meaning of function here. Now here you see, for every value of x we have a value of y. For every value of x here we have a value of y. So we can say y is defined for all values of x, because we are getting for every value of x we are getting a value of y. Therefore we will say y is defined for all values of x. Now for example, let us take another function fx is equal to x square minus 1 by x minus 1. In this function, if we choose independently, here independent function is a variable is x and dependent variable is fx. So if we choose x values 0, fx we are getting 1, x value as minus 1 we are getting fx as 0, like this. But when x becomes 1, fx becomes 1 square minus 1 by 1 minus 1, that is 0 by 0, that means meaningless. So that means fx is not defined at x equal to 1, because we are not getting any value of fx for x is equal to 1. Therefore we say fx is not defined at x equal to 1. Now in such case, we are not able to find the value of fx at a particular value of x. So when at x becomes exactly 1, we are not getting value of fx. Now let us see what happens if we take x slightly greater than 1. If we take x slightly greater than n, what happens to the value of fx? Let us see. Now what we will do is, we will take x value slightly greater than 1, that means 1.1 let us take. Then by decreasing its value, we will bring it nearer to 1. Now when x equal to 1.1, fx is equal to 1.1 square minus 1 by 1.1, that means we are getting 2.1. Value of fx is 2.1 when x equal to 1.1. Now let us decrease it. Let us take x equal to 1.01. We are getting fx is equal to, similarly if we put 1.01 in the place of x, we are getting 1.01 whole square minus 1 by 1.01 minus 1. We are getting fx equal to 2.01. When x equal to 1.001, we are getting fx equal to 2.001. When x equal to 1.0001, we are getting fx is 2.0001. That means this clearly shows that as x moves closer to 1, fx also is moving closer to 2. This is known as in the terms of limit. This is written in this form: limit x tends to 1 plus fx is equal to 2. Limit x tends to 1 plus fx is equal to 2. What is the meaning of this? That means here 1 plus, that means we have taken x slightly greater than 1. And when we are moving from a slightly greater value, when we are moving closer towards 1, fx is moving closer towards 2. This is also known as a right hand limit in the language of limit. Now let us, what we will do is, similarly let us take x slightly less than 1. Here we have taken slightly greater than 1, here we will take slightly less than 1. Then we will go on increasing its value and we will bring it close to 1. So let us take x equal to 0.9. We are getting fx is equal to 0.9 whole square minus 1 by 0.9 is 1. That means we are getting 1.9. Now if we increase the value 0.99, we are getting fx also getting slightly increased, that is 1.99. If x becomes 0.999, then fx becomes 1.999. So here you will see, as x increases and goes close towards 1, fx also moving closer towards 2. That means here we have taken x slightly less than 1, 1 minus means slightly less than 1, 1 plus means slightly greater than 1. We have taken x value slightly less than 1, and from a slightly smaller value, when we are slowly going towards 1, fx also moving towards 2. This is also known as left hand limit. So when we are moving from a slightly greater value towards the value of x, then we are saying the limit is right hand limit. And when we are taking the value of x slightly less and moving towards the given value, then we are saying it is left hand limit. Now this entire fact, whatever we have done, is expressed as limit x tends to 1 fx is equal to 2. So what is the meaning of this? This meaning is, for example here, this is x is equal to 1. Now we have taken slightly greater value, that means 1.1, and from 1.1 as we move towards 1, what happens? fx moves towards 2. When we are taking slightly smaller value, that is 0.9, and from a smaller value, as we are moving from a smaller value towards 1, fx also moves towards 2. That means whenever x moves towards 1 from either side, fx moves towards 2. And this entire fact is combined in this form: limit x tends to 1, fx is equal to 2, or limit x tends to 1, x square minus 1 by x minus 1 equal to 2. So what is the meaning of this? Means as x approaches 1, the given function x square minus 1 by x minus 1 approaches 2. In general, whenever x approaches a particular value a and fx approaches a particular value L from either side, from left hand side and also from right hand side, we say that limit x tends to a, fx is equal to L. So this is called the limit of a function. And this value does not give you the exact, when x is exactly equal to a, this value is, that is not f of a. This will give you the value of fx as x moves towards a, not x becomes equal to a. Now we have done lot of things here to find out limit of a function. But is it possible to solve the problems actually doing like this? No, it is very difficult. So we are having some working rules for finding limit of a function. Now let us see the first rule. Whenever we are getting a function and we are told to find the limit of a function, what we will do is, we will just put x equal to a in that function, roughly. And if we are getting a definite value for the value f, for the function fx, then we will say the limit of the function is equal to f of a. What we are doing, we will just take x equal to a and put the value of x in the given function. This is the function. We will put in place of x, we will put a, and if we are getting a definite value, then that also becomes the limit of the function at that particular point. To understand this, let us take this example. Limit x tends to 1, 2x square plus 3x plus 5. This is the given function, 2x square plus 3x plus 5, and we are told to find the limit as x approaches 1. So what we will do is just take x equal to 1 and put in the function. So 2 into 1 square plus 3 into 1 plus 5, we are getting a definite value 10. So this value is called f of a. Yeah, this value is called f of a or f of 1 in this case. And this is also the limit of the function. Now here f of a is determinate. So we are equating the f of a as limit of the function. But if f of a is indeterminate, that means if it is in the form of 0 by 0 form or something by 0 form, that means indeterminate form or undefined form, in such cases what you have to do? We have to do the following. We have to adopt the following two rules, that is rule 2 and rule 3. Now rule 2, for example, the given function is a rational function. So if the given function is a rational function that is in the form of p by q form, so what we will do is we will factorize the numerator and so also the denominator and cancel out the common factors. And after cancelling out the common factors, just put x equal to a, and there won't be any trouble. You can able to solve the problem easily. For example, let us take limit x tends to 2 x square minus 4 by x minus 2. If I am here putting directly x equal to 2, what is happening? 2 square minus 4 by 2 minus 2 means 4 minus 4 by 2 minus 2, which is come in the 0 by 0 form, which is indeterminate. Therefore, I can't put the value of x directly in this function. Therefore, what I have to do? I have to do first, because it is a rational function. So, what I have to do is, I have to first rationalize it, factorize it. So, limit x tends to 0, x tends to 2, x square minus 4 means it is in the a square minus b square form. So, let us put x minus 2 into x plus 2 by x minus 2, x minus 2 common factor cancels out. Therefore, which is equal to limit x tends to 2 into x plus 2. Now, in this function, you just put 2. So, you are getting 2 plus 2 is equal to 4, and this will give you the limit of the given function. Now, let us take one more example. Limit x tends to 1 x square minus 4x plus 3 by x minus 1. Now, just see as per rule 1, just put here 1 square minus 4 into 1 plus 3 by 1 minus 1. You are getting 0 by 0 form. Again, 0 by 0. And therefore, we can't put the value of x equal to 1 exactly in this function. Therefore, what we will do? Again, we will factorize it. Limit x tends to 1. It is a quadratic equation. So, let us factorize it like this: x square minus 3x minus x plus 3 by x minus 1. Which is limit x tends to 1 x minus 3 into x minus 1 by x minus 1. X minus 1 cancels out. Now, limit x tends to 1 into x minus 3. Now, put the value of x equal to 1. So, equal to 1 minus 3 equal to minus 2. This is how we can solve a limit of a rational function. Now, if the function contains a surd, then how to solve the problem? Now, if it contains a surd means what? Surd means the irrational numbers which are positive integers and the value of roots cannot be determined. You see this, for example, this is the function. Here you see root over 1 plus x minus root over 1 minus x. Here it is in the form of root. So this type of functions are known as surds. So they are irrational numbers like root 2, root 5, cube root of 17, etc., which are positive integers, no doubt, but their values of roots cannot be determined. You can't find the exact root of that particular function. In such cases, it is known as a surd. So in this case, what we will do? Simplify by using conjugate surds. Just we will use conjugate surds. We will multiply the numerator and denominator using conjugate surds, and then simplify it, and then put the value of x equal to a, whatever is given x value, and then you can easily solve the problem. Now let us take this example. The given example, limit x tends to 0, root over 1 plus x minus root over 1 minus x by x. Now its conjugate surd is, in the place of minus it will come plus, so conjugate. So I have just multiplied with the conjugate surd with the denominator and numerator, and I got limit x tends to 0. This becomes a minus b into a plus b, that is a square minus b square, by x into root over 1 plus x plus root over 1 minus x. Now this, okay, which is equal to limit x tends to 0. By simplifying it, a square minus b square becomes 1 plus x minus 1 minus x by root over x into root over 1 plus x plus root over 1 minus x is equal to limit 1 x tends to 0. Opening the brackets, I am getting 1 plus x minus 1 plus x, 1 cancels out, x becomes 2x, then x cancels out, and I got limit x tends to 0 into 2 by root over 1 plus x plus root over 1 minus x. Now if I am putting here x equal to 0, I am not getting any trouble. So now put the value of x equal to 0 here to solve the problem, and I am getting 1 here. So this completes about limit. So if you understand this much, then you can solve any type of problems in limit. But remember, you must know all the formulas, trigonometry formulas, and factorization of equations, etc. Okay, thank you all. If you like this video, like, share and subscribe it, and pass on to your friends. Thank you.